All right, well, thanks for coming, everyone. I'm excited to do this and a little intimidated. I know there's some expectations out here to prove that this is better than Nginx or something like that, but we'll clear that up. So tonight we're going to talk about serving the web from a more modern perspective as far as some certain characteristics like productivity and efficiency and things like that. And so a little bit about me is my name is Matt Holt. I grew up in Iowa, live in Provo currently. I just graduated from BYU in computer science a couple months ago, and I'm applying to the master's program there. So hopefully I get in and would start in the fall if I get in. So you can see my GitHub and Twitter here for a good time. Follow me on Twitter. And you can also check out my other projects on GitHub. I do some JavaScript, and I've, in a former life, did some PHP work. Ever since I discovered Go, I've never looked back. And it's been great, actually. But I love programming. I love writing code that makes people sit back afterward and they're like, wow, I really enjoyed using that. Or, wow, that was really cool. I've never seen something do that before. And so my other project on GitHub that's somewhat popular is PapaParse, which is a CSV parser for the browser, but it can process files that are gigabytes in size without crashing. And that's really fun to see people using that and just loving it for being so easy and intuitive. So I decided to bring this to the server side a little bit. So this is the Caddy website. And to give you a little bit of an introduction, you'll see that the first thing that it is the HTTP2 web server with automatic HTTPS. That's a lot of HTTP stuff. But Caddy from the very beginning has always been HTTP2 capable. It's been written in Go, and automatic HTTPS is a recent addition, and it's the only web server to use HTTPS by default. It's a web server that's comparable to Nginx and Apache, HTTPD, and IIS, and Leidy, and others that you may be familiar with. So it's the same kind of idea. It's a program, and you run it, and it answers clients who are requesting HTTP or resources over HTTP on various ports. And so, was there
I have a quick question.
Yeah.
What's your relationship to the project? Are you a contributor, user?
I'm the author of it.
Originally?
Mm-hmm.
Is it the primary contributor, or is it a lot of pull requests now? Or?
There's a lot. It's a busy project. I was actually just going to talk about that too.
Sorry.
Yeah, no, it's fine. I'll introduce you to the project as a whole and my relationship to it. And then we'll get into some details, some technical details, and why you might find it interesting. So it's comparable to Apache and Nginx and others that you've used. But what's unique is that it's written in Go, which I actually think is a huge and important factor, not because no one else could do it or anything like that, but being written in Go, it has a really solid network like foundation. The standard library, the Go standard library, is famous for being developed by the inventors of UTF-8 and the author of Memcached, and so it's got a very solid web core. It also means that being a Go program, it's cross-platform. So you can compile this for any system: Linux, Windows, Mac, BSD, Android. I got it running on my tablet a few weeks ago just for fun. It's also a self-contained binary, which means that there's no resources, there's no dependencies that it requires externally to the binary file itself, which means that you can plop this thing down in a Docker container that doesn't even have libc installed, and it'll still run with all of its features, and it's 100% independent of anything else on the outside. And after today's CVE and libc, that's a huge bonus, because you don't find those kinds of bugs in Go programs very often. So this project's a little over a year old. I started it at the end of 2014 when I stopped working at Smarty Streets, where I worked for a few years in Provo doing address verification, where I was introduced to Go. And I did this on the side of my schooling. And actually during my hardest semester, I was in 4 CS classes, and they were all 400 level, intense programming and mathematics stuff. I would never do that again, but it was awesome. And I started this so in December, a couple Decembers ago, and I kind of went public with it. I announced it in April last year. And since then, the project's had about 55 different contributors submit pull requests, and we've, I think, reached over 600 issues now, and just over 4,000 stars from this weekend, which is really fun. I didn't expect this. It's a little intimidating too, because this was kind of spike code. It was an experiment, and it was good though. And so now we're cleaning it up and making it work better. But I think a large part of its popularity has been in the last couple months when it got a new feature, and that was that it's now HTTPS by default. And like I said, it's the only web server that does this. I'll talk about that in detail later. It's also extensible and embeddable. This means that you can write plugins for it. Plugins are just code that run in the background while the server is running, or they can handle requests. So you can do your own custom thing to handle requests. Embeddable, meaning that you can run this in your own Go programs. If you need to, let's say you're developing a web app, but you also need a really solid static file server, and your custom, let's say your workflow, it just is better for you to embed the static file server in your web app. You can do that with just a couple lines of Go code. Just import the Caddy package. So at this point, Caddy is serving the local development environment for thousands of web developers across the world. And a lot of these contributors are not in the United States. I've actually been to Amsterdam and London and have met others. And it's really cool. Like, it's really exciting to meet people that you're like kind of chatting with and sharing code and doing code reviews with who are across the ocean. Our other core contributor, Abiola, is in Nigeria. We have others in India and South America. And it's really fun to see this global effort kind of come together. It also powers production websites, like real websites that get traffic and get sales and things like that. The GopherCon website is powered by Caddy, as well as sites like cssminifier.com and Gogs, which is a Go-powered Git service, kind of like GitHub, but it's self-contained and free and open source, and a lot of others. So I'm actually like really pleased, and I'm hoping that Caddy will be used more in production, because I think it's an important movement to change everything from HTTP to HTTPS, and that's really its kind of shining feature here that I'll highlight more later. Question I get a lot is, how fast is it? It's fast. Don't worry. It's fast enough for most people. It's faster than Apache in some of our basic benchmark testing, and it's about as fast as Nginx in some basic tests. Now, there are a bajillion use cases I'm not considering, and so I offer these remarks with the disclaimer that you should do your own benchmarking if you know what you're doing. I don't even know if I know what I'm doing when I'm benchmarking, but if you really need to push 100,000 requests a second, maybe you should stick with Nginx. But if you're okay with like 30,000 requests a second, you could use Caddy. Most people will not run into performance issues. Okay, so at this point, I would be a little remiss if I didn't mention a sponsor. This is the only way that I'm able to maintain this project right now, because by choice, I don't have like a regular job. I do contract work and rely on sponsorships and donations to be able to continue working on this project. And so Arroyo Networks does network testing software. They're a new startup out of Michigan. And I'm very grateful that companies and individuals are jumping in to contribute to this. Okay, so before going into details, I want if you have your computers, I hope you can pull them out, and I want your help with kind of a magic trick for later on. I want you to take a domain name, maybe a spare one that you have laying around, or make a subdomain that you can throw away after tonight, but point it at this IP address. You'll create an A record in your domain's, your zone file. And just kind of create that record with a low TTL. You don't need to load it yet because we kind of want to experience this together. If you, for example, if you're using Namecheap, you can just add a line in your DNS settings. This creates a subdomain called test, and then you just point it at that IP, and then set a low TTL just in case, and you can throw it away after tonight. The IP will stay in the corner of the screen through the presentation, so you don't have to memorize it. But if you want to participate, I can support up to, I think, 10 people doing this, but go ahead and try if more people want to. Any questions on this before I go on? Okay. So, let's talk about where this project came from and why. Like, what does it mean to serve the web like it's 2016? Why make another web server? So, I think that we should look back as to a few decades here into the 1990s. And these are the dark ages of the internet. If you remember, nothing was standardized. There was no concept of security. There was no concept really of hacking. Like, that wasn't like, attacks and man-in-the-middling and surveillance. They weren't really issues. No one really cared because the internet was still a toy. Everyone was experimenting with it. Everyone was doing with it their own kind of different thing. And so if we were to chart the kind of landscape of how developers and site owners interacted with and used the internet, I suspect it would look something like this. This is not scientific. Don't hold me to this. But if the area under this line is 100% of site owners and web developers, and along the x-axis is different priorities or workflows that they have or they put into practice, then I suspect in the 90s you would see something like this, where everyone was trying this wide variety of things, trying to make it work was probably the main goal, right? Trying to get the website up, and trying to maintain it and make sure it stays online, and so I think, that's probably most of this bump, honestly. And you see tools start to arise, like Apache HTTPD was, kind of the original web server, a static file server. But you have all these other technologies and other techniques under here and workflows, things like CGI, like Perl and PHP. You have XML, you have Shockwave, you have Java applets, you have SOAP, you have SSL. You have Mosaic Landscape and Netscape browsers, which was an attempt to make some sense of what was available on the web, make it available to people without having to parse through all this stuff themselves, and to link it all up with hyperlinks. And speaking of hyperlinks, HTML and DHTML and XHTML were all coming out. Am I the only one that looked up DHTML tutorials back when that was still a thing? Yeah. So I'm glad that's not anymore. But you see, that's what forms this x-axis here. And the way that they deploy these sites and the way that they run them is all along this x-axis. And I don't think that there was much consensus, honestly. But if you look at the landscape of the web now, I think in 2016, it would look a little more like this. And so again, you've probably got about 90% or 80% of the developers and site owners in here somewhere under this bell. And what caused this after 2 decades? What caused us to kind of all get the same basic workflow? We're all trying to do the same basic things, and I wouldn't suggest that this is because of a dearth in tooling or frameworks. I wouldn't suggest it's because there is nothing over here that people aren't using it. In fact, there's more. There's thousands of ways to make a website, right? But the basic goals and the priorities and the workflows, the way we deploy, the way we develop, is starting to congregate toward these common characteristics. And I think that this bell is caused now not because of lack of tools, but because of just massive saturation. I think that we're seeing the internet accessed by billions of people on the earth. And by the way, there are only billions of people on the earth. Billions of websites are on the internet. Billions of devices are connected to it. And this saturation, I think, is what's causing people to want to just pump out websites, pump out web services. It's a routine thing now. And actually, we're pretty good at it, right? Like, we're good now. We know that HTTP is like the de facto standard for producing web content. We know that Linux is kind of the de facto operating system to run it on. We know that we need to think about security and performance. We separate our front-end static resources from our dynamic resources and assets in the back, our applications. And there's things like Docker and virtual machines and CDNs and proxies and all these other things now line the x-axis. But what's in this red patch? Well, I think it would be things that you're probably very familiar with that are now like basic to us, and that is things like your website should be static unless you really need it to be dynamic, right? Don't use CGI unless you have to. Don't use a database unless it's really needed. And if it is needed, you can probably outsource it somehow, like use API calls and all this other stuff. As a developer, as a web developer, I find myself often, CDing into a folder where my site lives, and then just wanting to just run a command to work on that website. And just simplifying our workflows, making them more routine. We have developers now that are working on dozens of sites at a time or within a short period, not 12 developers working on one big site, typically. Because developing a website these days isn't so much just creating HTML files and then uploading it through FTP. Remember how everyone can see your transmissions if they're watching your network? We have this workflow now where making a website is more like stitching together different web apps and proxying certain URLs to various ports and backend services and putting a CDN in front if we really want to scale to global audience and be able to survive a flood of traffic. So in this red patch too, I would say we also have things like compression, things like performance improvements like HTTP 2 instead of just HTTP 1.1, which we've been using for 20 years. Things like using multiple cores to serve requests. Nginx does this with kind of a worker model. Caddy does it using multiple cores within the same process, and it scales across those cores very well. We talk about caching here. We talk about scalability, maybe more out here on the edges. Containerization, probably more out on the edge still, but cloud instances and load balancing and security, of course, is in here now too, is encrypting all the things. In fact, we have laws that require certain things to be encrypted and secured, and there are federal standards. So I guess the ultimate answer to this question is why another web server is to try and serve the needs of this 90% or 80% or whatever it is as best we can. We want to keep developers productive. We want to keep site owners where they hit that, their sweet spot kind of. The tailing end here is served great by those tools that have been around for ages or are very specialized or are very low level or are very proprietary. And so I'm not actually worried about those because other tools will always exist to serve that. And so in order to serve you well, Caddy makes some assumptions. First, it assumes that you're working at the HTTP layer. So if you need a raw TCP proxy, for example, Caddy's not for you. Caddy assumes that you're working at the HTTP layer, and only HTTP, not some orthogonal protocol like SMTP. It's not a mail server.
So WebSockets?
It does do WebSocket proxying, which, you're right, you caught me. That's a TCP proxy. But it does initially start with an HTTP connection, which is then upgraded. Unfortunately, too, HTTP 2 doesn't support WebSocket. It doesn't support protocol upgrades, surprisingly. Hopefully it will in the next revision. But I think they forgot or something. I don't know. And actually, it's kind of debatable because HTTP 2, with its properties, could arguably replace a WebSocket connection for certain things. So we also assume that your site has a logical folder structure. Again, Caddy relies a lot on the URL path for things. It's not a powerful matcher like you may be used to relying on with Nginx or Apache. It assumes that it wants to encourage you to create a clean folder structure for your site, to componentize and put things into places that make sense. You wouldn't want static assets being here and here and here, and maybe proxy everything that starts with this URL unless it's this URL or this URL. And we try to avoid exceptions to the rule. We try and keep it simple. And you'll see what I mean later. We also assume you want security without thinking about it, and I'll explain why that's really important. We assume that if you're serving a live site, that ports 80 and 443 are available. Again, it's necessary, and I'll talk about why. We assume that you own all the sites you're serving. So if you're running a shared hosting environment, this may not be ideal. I don't see Nginx used, for example, very often in shared hosts environment. Apache is still...
It
is it? That's cool. So...
What actually uses Nginx to do all of their proxy things.
Okay, cool. So there are shared hosts that use it to proxy to various things, and I guess it depends. I've just seen Apache used a lot for that. But anyway, if you do anything fancy too, we just assume that you know what you're doing. And if you want to do something fancy, you've read the documentation, you understand the implications at a system level. Caddy doesn't really try and protect you too much. So this name, Caddy, I get a lot of questions about this, and I still wonder myself sometimes why I chose what I did. And so I made this slide to try and convince myself that it was the right name. And I actually waffled on this for like 4 months. I couldn't decide what I was going to name this. And so if you Google this, you'll get image results, for example, for this thing, this car. I guess that's a caddy. And then for the shower organizer and this desk organizer, which I think is just charming in pink. But these are caddies, right? They organize, I don't know what this is, but they organize things for you. And if you spell caddy this way, with an IE, it tends to refer to a person, like a golf caddy, that carries your bags and gives you advice and kind of runs random errands for you. And so the caddy with a Y being a thing, caddy with an IE is kind of a person. Some dictionaries allow both. I kind of like the terseness of just having spelled with a Y on the command line. And I do like the human touch of the IE spelling because this web server is designed for humans, to make things easy for the human. Although I don't think we're at a point yet where we should start referring to programs like we do as people. Like honestly, I think it's weird talking to Siri and giving it a name. I just think that's weird because it's not a person. So anyway, let's show you how this works, right? We'll just do a quick tutorial. And yeah, because I think it'll make more sense if we talk about the internals, if you know how it works as a user. So to run Caddy, it's really easy. Once you have the binary, which you can download from the website, you just cd to the folder where your site is, and then you type Caddy and you hit enter, and it'll start serving that current directory and all the static files within it. That's really all there is to it in a development workflow. I love this workflow. If I'm working on like 10 sites, if I want to switch and work on a different site, I just cd to that folder, and I just run Caddy. And it just starts serving it, and it's a production-ready web server. And it'll serve it on localhost port 2015. And so you can go to that in your browser, and you can just start using it right away. You can customize the host. You can customize the default port with little flags. No big deal. You can also invoke certain features right on the command line without needing a config file. So if you wanted to start a file browser or allow people to see files in a certain folder, you just cd to that folder, type caddy browse, and it enables the browse middleware, the browse feature. And it'll allow you to kind of explore your folder. So here you can see all my nerdy space exploration pictures and notes and things. And this is all just default built into the server. So there's a few different ways to run it. And if you really want to get the full experience, you should make what's called a caddy file. And I get some flack for this because, yes, it's another file, and it's another syntax. It's not JSON, and it's not YAML, and it's not Nginx, and it's not JavaScript, and it's not a programming language. It's not CSS. But it is declarative, and it's very clean and intuitive and easy to use. So I have very specific reasons for coming up with this format, and you can read about it on the blog if you want to learn more. But basically, what I wanted was a way to just cd into a folder, and when I run Caddy, I just want it to load the config file from that same folder. So if you have a Caddy file in the current directory, it'll just load it and use it. And I just wanted to be able to put into this file just some things that I wanted my site to use. So, for example, if I wanted to develop my site with gzip, I just type gzip, hit enter. And if I want to serve my site with clean URLs that don't have like the extension in the URL, so if I want to assume a .html extension, I just type ext space .html and hit enter. And it'll serve clean URLs that way. So basically what you'll do is you'll create a Caddy file for every site you make. And the Caddy file lives with the site or around it. You can specify where it is to Caddy by using the conf flag. And this is all on the website and the documentation. But if it's in the current directory, it'll just use it. And so it makes it really easy. So Caddy file, we'll look at a few examples here. Caddy file always starts with the site address. So that's the first line. And this is the address that you want to serve on. So in this case, it's a development site serving just on localhost. So it'll default to port 2015. That's Caddy's default port. And I hit enter, and I just start listing off what kind of features I want this site to have. So Markdown. I want it to serve Markdown files. I want it to render Markdown as HTML, basically. And so just by putting that in there, it'll render all the Markdown files as HTML. I talked about clean URLs. So the ext directive is what it's called. The first word of every line is a directive. And so ext then will assume HTML file extension and then an MD file extension. If HTML doesn't exist. Log will enable a request log or an access log. Errors allows you to specify an error log and custom error pages. So you can probably spit this file out in about 30 seconds and have all this just kind of work with that site. Here's a list of all the directives currently that you can use. And they're really easy to use. I'd like to think they're really well documented. They do what you would think that they do. Basic auth configures basic auth. Browse enables a file browser. These green ones are add-ons or plugins, which I'll talk about more later. But a few notable ones would be Git. So this will allow you to deploy your site with a Git push, and Caddy will pull the new site and start serving it. Hugo is a complete Hugo integration. Hugo is a static site generator written in Go. And if you get Caddy with the Hugo extension or with the Hugo plugin, you actually get a web-based editor where you can create files and write them in Markdown and then hit publish, and it will publish your site. And it's all built into your web server, if you choose. So add-ons do not come with the binary that you download unless you check it and ask for it. Otherwise, the binary does not get bloated with all these features, all the green ones, unless you want it. FastCGI will proxy FastCGI requests to your PHP backend, for example. gzip proxy, this one's cool. We'll look at that in a bit. WebSocket will proxy WebSocket connections. Actually, correction, this will proxy WebSocket connections. This will proxy them in a special way so that it'll actually work with any program that reads from standard in and writes to standard out, and it will relay that through a WebSocket connection. So your program that actually, your app or your backend doesn't need to know WebSockets. It doesn't need to understand it. Just write to standard in or write to standard out and read from standard in, and you can use it with your website. Shutdown and startup are functions that can execute when the server starts and when it stops. So we'll see an example of that later. Rewrite and redirect. I mean, all of these are things that you would expect to find in a web server like Nginx or Apache or Lite or something.
What's internal?
Internal is a directive that protects certain assets from being requested by a front end, but allows them to be requested by a proxy backend, kind of. Yeah. There are specific docs on internal. I actually didn't write that one. A lot of these were actually contributed by other people. This proxy middleware actually implements load balancing and health checks and stuff. I didn't write that. That was a third-party contribution, which is really cool. I didn't write most of these, actually. So anyway, here's another example. Here we're actually serving two sites. And so we've got them enclosed in curly braces. That's only necessary if you're serving more than one site from the same file. And the www version here just redirects to the cleaner version, I guess. And so here we're setting the root folder of the site to be here. We're enabling gzip. We're proxying FastCGI to a FastCGI backend for all requests that start with /API. And it's a PHP backend. And so that's really easy. If you've ever read tutorials about how to set up Nginx to proxy your PHP stuff, all the tutorials are different and have security problems. This is really nice. One line, and it's all the same everywhere. Startup and shutdown. So you notice that when the server starts, we start the PHP process manager, and when we shut down, we stop it. So you don't need to do that separately. Great for a dev environment as well. Here's a third Caddy file. Here we're serving one site, but on two host names, example.com, and then one that we pull from the environment. We have a simple echo server over WebSockets here. Just by any request to /echo will be upgraded to a WebSocket connection that communicates with cat, which, as you know, its input is its output, basically, and so it's an echo server with one line. It enables directory browsing in the /public folder. It pulls the latest site from this GitHub repository. It compresses all the responses. It proxies all requests to /webapp and child paths to these two backends, and it does load balancing and health checks. So if one goes down, it'll still use the other one. And then basic auth, of course, protects the web app with a user and a password. Okay, so a little bit about some of Caddy's primary features other than those middleware and those directives we were talking about. First, let's talk about automatic HTTPS. Now, I'm really passionate about this because I believe strongly in security and privacy on the web. And so automatic HTTPS is my answer to the security problem that we have, which is that it's kind of a plague, and that is that everything is plain text unless you know how to set up an encrypted connection and you have the money to pay for the resources to do it, and you even think to do all this in the first place. So automatic HTTPS is the answer, and it's really not going to happen any other way. But what this means is that all live sites are served over HTTPS without you asking. There's no action required by you to get this to work, except that you have to agree to some legal terms depending on your certificate authority. Caddy takes care of all the cryptographic assets like certificates and keys, and it renews them, and it will staple OCSP. And you can turn this off. I don't recommend it, but there is a way to turn it off in the Caddy file. So this is really cool because Caddy can actually obtain and renew the certificates that allow your site to be served over HTTPS. So I don't do this alone though, and I really can't take credit for this because Let's Encrypt is what makes it possible. If you've heard of this, it's a free certificate authority, and the only way to use it is through automated means. You have to use a program that talks to its servers, and they're really pushing automation, and honestly, I think that's the best way to go. It's the only way to do it. If the CAs, so a little bit of background, by the way. If you're not familiar with serving a HTTPS website, what you need to do in order to get that green padlock in the browser is you need to get something called a certificate from a certificate authority. And a certificate authority is a company that basically vouches for your site and says, yes, I've confirmed that you are the owner of the site, so here's a certificate. And the certificate just basically has some magic numbers in it that when the browser downloads it, it's able to verify that, yes, this is the real website I'm talking to, and it also enables encryption. So you are reassured in the fact that you are talking to the website you think you are talking to, and your communication is private. And we absolutely need that today. Well, the problem is that up until Let's Encrypt, the only way to get a certificate basically was by paying about $10 and then clicking a link in your email whenever it showed up. And then eventually they would email you a certificate. And you had to run a lot of commands. You had to generate a CSR in your server and private key. And then you had to, this process could take hours, a couple days, and it cost money. But with Let's Encrypt, it's free and it's automatic and it's real. Like, this is a trusted certificate authority in all the browsers. So Caddy leverages Let's Encrypt by using a protocol that they've pioneered called ACME, Automated Certificate Management Environment, I think. And it basically allows you to get a certificate for free and renew that certificate and revoke it if you need. And a really cool thing about Let's Encrypt is if your site is compromised and your private key is leaked, then anyone who has the private key can revoke the certificate. And so you've kind of crowdsourced your policing of public key infrastructure now. It's a great thing. Let's Encrypt certificates are only valid for 90 days, and they do need renewal. And so Caddy takes care of that. And it also generates certificates when you first start the server for your sites. And so here's actually a short video of Josh Oz, who is the executive director of the Internet Security Research Group, which is the organization that owns the Let's Encrypt brand. And he's talking about here different client experiences. And this is not an endorsement by him or Let's Encrypt or anything like that, but I thought it was a cool demo and gives you an idea of how this works.
Nginx in particular, you configure it to set up a secure website. It will just get a cert, install it for you, and manage it for you. And ideally, you won't even need to know that you have certs so that Apache is getting certs for you. But 3 is really the best client experience. Well, there is a server out there that does this. It's called Caddy, made by a guy named Matt Holt. He was an early adopter. And Caddy is impressive. So this is what we want setting up a secure website to look like from start to finish. He's going to edit his config file here. say that he wants to set up the domain map.life. I'm going to start the server. Now it's negotiating Acme and getting a cert. Done. Enables HTTPS. I got the website. Got a lock. It's secured. And it's got a cert from Let's Encrypt.
So, and as he says later in the video, this is the only way we're going to get to a fully secure web. And I agree, because I don't think people are going to care enough until they've had a problem to enable the security. And most of the time, I don't think they'll know that they've had a problem, that their customers or their visitors are having ads injected on their site. I don't think they're even going to know. I don't even think they're going to know their ISP is selling their browsing habits to other companies because they've been injecting code into the page because they're not using HTTPS. I don't think they're going to think about the fact that the government is able to store and analyze massive amounts of transactions that happen over the internet unless it's encrypted. So I'm a strong believer in encryption, and I want to make sure that every site has it. These are not things that Apache or Nginx do right now. And so I'm not going to say that's better or anything, but it is just different, and I hope that it will catch on. So that domain that you set up earlier, all of you that did create a new A record, I want you to load it now in your browser. And I want you to look at the URL bar and see if the demo gods are pleased with us tonight. Let's see if this works. How many of you set up a domain name to try this? 2, 3, 4?
My local host, hoping that would fix it for me.
Oh. It has to be a public domain. Sorry, I should have clarified. It has to be a real domain accessible through root DNS. Yeah?
Absolutely work.
Getting a self-connection error.
Oh, that's fun.
If I post file Google to you, it gets a protocol error.
Yep.
If you what?
If I try and access Google with that URL, it gets a protocol error. But I have a success here. I have a green bar on my domain.
Okay, so it only works for, I have some rate limiting set up for the demo. It only works, I didn't expect this many people. It only works to the first 10, so you'll get protocol errors for the rest. This is a prototype of the next version that's coming out. Yeah, so this is this worked. So what happened here for the first few that got in before the rate limit was hit was as the TLS handshake was happening, Caddy requested a certificate for your domain and served the TLS handshake with that new certificate. And so some people are seeing a success here and a little welcome message with your IP address and the domain name.
I think that deserves a round of applause.
So Caddy's the only server that will be able to do this. This is coming out in version 0.8.2 in the next couple weeks. I'm waiting for Go 1.6 to get released, which I think will happen tomorrow. Yeah.
So use case for this versus requesting it on server startup would be?
Good question. So you don't need to know or configure the domain names beforehand. And this is a complicated issue, so I'll spend just a few minutes and talk about that, and because I think this is the most important part, is the HTTPS stuff. Anyways, so Let's Encrypt, being a real CA, being a new CA, they have put in some tight rate limits for their beta period. They're still in public beta. And so right now you can only request 5 certificates per second level domain per week. A second level domain being something like caddyserver.com. Caddy server is the second level domain, so any subdomains to it also are included under that same rate limit. So it's really tight. So this feature isn't restricted to just the same second level domain. It works for any domain name that you may have. So for example, I'm actually doing contract work for a company that has about 2,500 second level domains that they need to serve. And if you don't want a 2,500 line caddy file with all those domains listed in it beforehand, all you have to do is set the address to be port 443, for example, and enable this feature by using TLS directive, and then you just specify the maximum number of certificates that you allow it to serve. Anyways, but the point is that you don't need to list all the domain names beforehand. And this is better than a wildcard certificate because wildcard certificates cannot be issued on top-level domains. So you can't get star.com, obviously. That would be a disaster. And so, but this will allow you to get any site on any second-level domain, as long as it's pointed to your machine, served over HTTPS without you having to obtain a certificate beforehand. And so it allows you to scale your operations really well. Again, this company goes through hundreds of different second-level domains a week, and without having to change or touch their server configuration, all they have to do is point it to the machine they're serving the site on, and it will already be served over HTTPS. You cannot do that with a wildcard certificate. So those of you that got protocol errors, it might start working again in 10, 15 minutes. Hopefully. If not, let's talk. So, summary of HTTPS with Caddy is that there's two ways to use HTTPS with Caddy. One is you can do it manually. You can do it the old-fashioned way. If you have your own certs and keys, bring your own cert. And you can specify the certificate and key pairs. That's where you have the certificate bundle in one file and the key in another file, and you just say TLS and you list the files. Another way is you can specify a directory from which to load the certificates. That is a new feature coming out with 0.8.2 that kind of works hub proxy style, where you specify the directory and it crawls the directory for any PEM files, and it'll load those and use those. The other way is with managed TLS, which is what you just saw. That's where Caddy will create a certificate on startup. Those are preloaded certificates. And the other is if you can use on-demand TLS, which is a type of managed TLS that's tightly rate limited right now because you can imagine the potential for abuse here. But the on-demand TLS will allow you to get certificates during handshake time. And then after the first handshake, the certificate's cached and it'll be instant. If you're going to experiment with this, go have fun, feel free. But there's a flag, a CA flag, and if you are not quite ready to serve your site for reals yet, and you're kind of playing around, use the staging server. Let's Encrypt right now is the only Acme CA. Hopefully more will come up, but if they don't, for now you're stuck with Let's Encrypt, and they have really tight rate limits. The staging server is not subject to those rate limits. And sometimes Let's Encrypt bugs me because they're like, we see a lot of requests from Caddy and they're always hitting the rate limits. Is it a bug? And I'm like, no, we found out time and time again it's not a bug. It's just people destroying their Docker containers and starting them up again, which deleted the certificates, and so it has to ask for new ones, and you're doing it wrong. So, yeah.
And this may be a little too complex for right now, but like if you're putting this behind a load balancer, for example, and not doing SSL offloading on the load balancer, how is this going to behave when doing this authentication process to the Acme and stuff to sort of validate that it is actually serving it, even though there may be however many containers or VMs or whatever?
That's a good question.
Does it? If it's too much for an
No, it's fine. I can answer it pretty quick, I think. I'd actually rather focus on this topic and skip the rest of the stuff for tonight if we have to, because I think this is the key. But so his question was, how does this work behind a load balancer? Can we still obtain a certificate? How do we verify ownership if there's maybe numerous virtual machines or containers serving a site, a service? So the answer to that is there are 4 ways to obtain a certificate with the Acme protocol. And you, as a user, won't usually have to worry about this, except for maybe in these advanced configurations. The first way is HTTP challenge, where you simply serve a resource over HTTP, and the Let's Encrypt server has to be able to access that resource. It has to contain the right contents. And that's why port 80 is required. even if you're not going to even open port 80, you need it open because that's the only port that this challenge will work on. And you can talk to Let's Encrypt about why that is. But it usually works. Caddy is designed to serve this challenge very well. That can break in load balancing situations if Caddy's behind a load balancer and you're trying to solve the challenge on this one machine. You have maybe these 4 others, and so Let's Encrypt comes in to make to verify the challenge, and it gets balanced over here instead of to the machine serving the challenge. So there's another way you can do it called the DNS challenge, where you set a DNS record, and Let's Encrypt will check to make sure that record is set. It doesn't even have to hit your infrastructure at all. It just goes to DNS and back. And so that's probably the way you want to do it. Caddy will support that very soon. We're working on it. I'm also working with the author of a library that is written in Go specifically for the Acme protocol. Like, I've worked with him very closely now for about 8 months. He's over in Austria. His name's Sebastian. He's doing a great job working on this library that implements all of these challenges, and Caddy's using this library, and it will very soon support the DNS challenge. It actually already does, but that's complicated because you need to provide DNS credentials to Caddy so that Caddy can access your DNS provider, set a record, wait for Let's Encrypt to verify it, and then remove the record to clean up when it's done. But it will be able to support DigitalOcean, Cloudflare, Amazon Route 53, DN Simple, and a bunch of other DNS providers out of the box if you just simply provide the credentials.
So it does this, and then after it keeps polling and checks to make sure that it's happened or something, and then it goes and then makes a subsequent call to Let's Encrypt to actually pull down the cert.
Yep, exactly.
You
So
might want to ship it to your load balancer out of band, like, as a separate thing, though. Like, you want your load balancer that's not Caddy to serve these certs.
yeah, so there are a few infrastructure questions, architecture questions, right? You could use Caddy as your load balancer, and that solves all the challenge questions. If Caddy's behind a load balancer, you can provide Caddy the DNS credentials, and it will, and you have to tell it to use the DNS challenge, but that will work in a load balance situation. It just takes a little longer because there's polling involved. And today I saw an issue that was open. There's a DNS provider where it took 60 minutes for the text record to appear in the zone file. So that means that you're going to be spinning for 60 minutes just waiting. So it's not a perfect solution. I think that's a DNS issue. There's another challenge too, a TLS SNI challenge that's kind of cool. It's a lot like the HTTP challenge, but it takes place at the TLS handshake level, where the server has to provide an SNI name that the Acme authority says it needs to. And that all happens at the TLS level. But even if you set up your load balancing correctly to just go to the one serving the challenge, but if you're doing SSL termination at the load balancer, which I know you said you're not, but if you do, it's going to break the TLS challenge because it has to go through at the TLS layer to whoever's solving the challenge. It's complicated. You won't have to worry about a lot of those details, but it will be clearly documented, and it's already working, and we'll handle it better as time goes on. The Acme challenge hasn't been, like the Acme protocol hasn't been standardized yet. It's still a working draft. Okay, so I'm just going to breeze through this. This is how Caddy handles a request. It's pretty familiar to all of you. There's a TLS handshake where it will get a certificate. We're not using Go's built-in certificate cache thing that the net HTTP and the crypto TLS packages provide. We're using our own mechanism to cache and retrieve certificates. And then inside Caddy's serve HTTP method, this is kind of the main handler. There's a few things that happen. First is a defer recover, which is basically a Go way of saying, if you panic anywhere down here and you crash hardcore, I'll catch it, I'll log it, and I won't go offline. Request callback is this next thing, and that is basically some code that can be hooked in to handle a request before we even route it to the right host. So that's used to serve the Acme challenges, the HTTP challenge, for example, is that we check to see if the path is a certain Acme challenge path that would only be used in the Acme challenge. And if it is, then we serve the certificate challenge there to the CA. But otherwise, we just do a host lookup and see, oh, what host name are we trying to serve here? Because Caddy does virtual hosting, like you would expect. If it doesn't find the host, you just get an error message, oh, no such host being served. Otherwise, it executes the middleware chain, which is all those directives that you saw earlier. Every directive you specify chains in, it kind of ropes in a new handler. And these execute in a certain order. And they just pass the request down the chain so that all the directives you specified get executed. And the ones that you don't specify don't even get chained in, so they're not executed. So it's very lean and mean in that sense, very quick. Here's a way to deploy Caddy on Linux. You don't have to pipe stuff to bash. If you're panicking inside a little right now, it's okay. This is over HTTPS anyway. It's an experiment. You don't have to do it. Raise your file descriptor limit, especially if you're serving a production site. It's going to be busy. And then Caddy does not drop privileges yet. This is complicated with the Go runtime. So what you do is you can run it as a regular user if you use setcap. And this is where Linux is awesome, because binaries can have properties that allow them to have capabilities to do things like bind to low ports. So if you want to bind to a low port without being root, you can use setcap. And then you just run Caddy in the background. And honestly, this is how I'm running all my Caddy sites. This may not work for you if you are not comfortable with that. It's never gone down for me. Anyways, I like simple, but you can do what you want. You can put it behind a process manager or something like systemd and make sure that it's always up and whatever. But Caddy doesn't go down. It hasn't yet. Anything else on that? That was it. Okay, Caddy accepts certain signals. Here's what they all do. User 1 is the big one as far as Linux being awesome, because this is a graceful reload. So you can change the Caddy file in flight and then signal Caddy with user 1, and it'll reload the new Caddy file without downtime. So this is like Nginx in that sense. The difference is that Caddy gets a new process ID. If you care about that, there's a PID file it can write to keep track of it. And Caddy may in the future be able to drop privileges using the same idea here. You could run it as root, and then it could actually restart itself as a non-root user, but with the listeners already running on the low ports. But it gets a new process ID. So we're looking into that for privilege de-escalation. So downsides to using Caddy? Well, I'll be honest, it's fat. It's a large binary. It might be about 15 to 20 megabytes depending on your platform and what plugins you have installed. I know that disk space, that's not a big deal. Honestly, that's not a big deal, the large binary. It's self-contained. It's totally independent of any dependencies. The large binary is actually a benefit, I promise. The Go runtime is also a better scheduler than the operating system because it understands Go code, and so it can multiplex across these different cores more efficiently than, that's why Nginx uses a worker model, because threading actually doesn't perform as well, it turns out, in these cases. But in Go it does, and it's a single binary, it's a single process. Caddy is not as low-level customizable as Nginx. So in Nginx, you can do a lot of really crazy things at the system level. With Caddy, that's not always the case. But again, we're trying to hit that 80 to 90%. And in Nginx, a common workflow, for example, is to stub out a config file that kind of does all these rewrites and upstreams and custom servers and things like that. And you can maybe do that in Caddy, but the more Caddy-like way of doing this is to write Go code that does it, and then just plug it in to your binary and build it that way. Building Go programs are very easy. It's very easy to do. You can even just download Caddy with these add-ons pre-compiled in without having to install Go. it's a great process. So yeah, you can't do everything from the Caddy file, but you can write Go code that does it, and then just build it in. Caddy is fast, but it does need more optimizing, especially the reverse proxy. This is not saying the reverse proxy is slow. I know of several companies using it in production. In fact, it was a company that wrote and contributed this reverse proxy with the load balancing and health checks. Works great. Caddy's not a caching web server yet, but I would love to make that happen. If any of you are caching experts, would love to have your contributions. And then the build server that powers the download page is manually maintained right now. That'll be changing soon. In the future, going to have a REST API, so you can configure Caddy using any API client over authenticated HTTPS requests. This will allow us to have a GUI, like a web-based UI, to manage your server without having to touch the file system or log in or run commands or send signals. Going to have more tests, going to clean up the code, going to do caching. How hard could it be? Lua, there's a little experiment in the repo to have a Lua add-on. So I actually really like the PHP workflow. The PHP way of deploying an app was just you upload the file and then it just kind of works because it's interpreted. But I like Lua better because it can be interpreted by Go much more easily, all in process, and so you don't have to deal with process managers and FPM stuff. So that's kind of playing with that. And then how you can get involved. You can use Caddy, tell people you're using it, tell people if you like it or don't like it, honestly. Join us on chat. It's kind of an active chat group there, always something going on every day. Comment on the issues, submit pull requests, you can donate if you're that kind of person. You can write a plugin. That's actually really fun. There's a good tutorial for it there. It's very easy. And also you can sponsor the project. There are small opportunities and big opportunities depending on where you're at. But if HTTPS by default, like in fully managed security features like this are your kind of thing, like if you believe that we need to be encrypted and this is a good way to get encryption to everyone, I would love to talk about a sponsorship opportunity with you or your company, because there are ways for your company to benefit, obviously with a link on the website, and a mention in talks. And then bigger opportunities, we can go to a conference together, distribute some swag, put our names together. And so do let me know if you'd be interested in this, in funding the project to help it go forward. If your company does use Caddy to serve its website, I would like for your company to donate to the project, since your company is presumably making money from having a website, and Caddy makes that possible. So that's all I've got. They're all asleep. That's great.